We have different kinds of transport from the land, air, and sea. We can go to different locations in a very convenient way because of transportation engineering. So, transportation engineering deals with issues such as the development, management, and maintenance of transportation systems, as well as the design, planning, and execution of transportation systems. The transportation system has some characteristics that makes it complex and diverse. These are multimodal, multi-sector, multi-problem, multi-objective, and multidisciplinary. A transportation planner must take into account the strong links and interactions between transportation and the rest of society, particularly in light of the world's rapid change. It is essential to recognize four critical aspects of the transportation system's development among them, which serves as the foundation for choosing the appropriate perspective. So the four critical aspects of the transportation system's development are change in demand, change in technology, change in operational policy, and change in values of the public. Change in the demand, in which demand patterns, both in terms of quantity and spatial distribution, vary when factors such as population, income, and land use change. Transport demand typically manifests itself at certain times that correspond to recurring patterns in both economic and social activities. Many times the demand for transportation is predictable and frequent, making it possible to plan services with good approximations. In other instances, the demand for transportation is erratic and unpredictable, making it difficult to provide a high enough quality of service. Change in technology. As an example earlier, only two alternatives, which is bus transit and rail transit, were considered for urban transportation. But now, new systems like LRT, MRTs, etc. offer a variety of alternatives. The traditional transportation sector is very eager to embrace new technologies since there is no doubt that our transportation system is undergoing a significant transformation. New technologies are certain to completely transform transportation at the same time increasing the effectiveness of existing methods. Change in operational policy. Variety of policy options designed to improve the efficiency, such as incentive for carpooling, bus fare, and road tolls. So it deals with creating a set of concepts and claims that are developed to attain specific goals pertaining to the state of social, economic, and environmental concerns, as well as the management and effectiveness of the transportation system. Change in values of the public. Earlier, all beneficiaries of a system were monotonically considered as users. Now, not one system can be beneficial to all. Instead, one must identify the target groups like rich, poor, young, work trip, and leisure. So what is the role of a transportation engineer? There is a set of theory and a set of basic principles that must be applied in every analysis of transportation systems despite the diversity of problem types, institutional contexts, and technical viewpoints. The transportation system analysis methodology is at the heart of this. The connection between the region's transportation and activity systems is the subject of this. So in order to employ transportation efficiently in collaboration with other public and private acts to fulfill the aims of the society, this strategy involves carefully interfering in the intricate fabric of the society. For this, the transport engineer needs to have a solid grasp of transportation systems and how they interact with activity systems, which shows importance to the comprehension of fundamental theoretical ideas and available empirical information. So, transportation engineering can be broadly consist of four major parts: the transportation planning, geometric design, pavement design, and traffic engineering. Transportation planning essentially involves the development of a transport model which will accurately represent both the current as well as the future transportation system. By anticipating present patterns, it deals with development infrastructure for traffic in the future. It guarantees the transportation system's present and future needs are properly addressed and anticipated. Geometric design. Geometric design deals with physical proportioning of other transportation facilities, in contrast with the structural design of the facilities. The topics include the cross-sectional features, horizontal alignment, vertical alignment, and intersections. Although there are several modes of travel like road, rail, and air, the underlying principles are common to a great extent. Therefore, emphasis will be normally given for the geometric design of roads. Pavement analysis and design. Road structural design, including asphaltic and concrete roadways, usually referred to as rigid and flexible pavements respectively, is the focus of pavement design. It deals with paving material design, layer thickness calculation, and construction and maintenance methods. The design primarily addresses drainage, structural, and functional issues. The pavement is protected from damage caused by water infiltration by drainage design, which emphasizes the riding quality, and structural design, which makes sure the pavement is strong enough to withstand the impact of loads. The traffic engineer must first comprehend the features and behavior of traffic flow through a thorough analysis and collection of traffic flow data. Based on this analysis, traffic flow is managed to ensure that the transportation infrastructure is effectively utilized and with high-quality services. In a nutshell, a traffic engineer's job is to provide economic growth while protecting the environment, ensuring mobility, and assuring the safety and security of both people and cars through both accepted norms and cutting-edge communications. The objectives of transport planning is to improve coordination between land use and transportation systems, provide cooperative interaction between planning, design, and operation of transportation services, maintain a balance between transportation-related energy use and clean air, and encourage alternative modes of transportation that enhance energy efficiency while providing high levels of mobility and safety. Nearly one-third of highway fatalities are caused by or related to outdated road designs, roadside hazards, and poor road conditions. Effective transport in urban areas is essential to the accessibility of land, the productivity of growth of economics, an effective standard of living, and the overall environment of the city. To guarantee the safety of those on the road, transportation planning has the goal of ensuring that these risks and conditions are routinely fixed and are up to standards. The planning, design, operation, and maintenance of transportation systems are the focus of the extremely broad and complex area of transportation engineering. The movement of both goods and people must be done in a manner that is safe, efficient, comfortable, convenient, economical, and ecologically friendly. This kind of work has a clear social responsibility. Transportation planners and engineers are aware that transportation systems have a significant influence on how a community develops. Planning and building transportation infrastructure typically improves overall living quality and societal values.